This paper presents an exploratory study of augmented reality presence for machine task tutoring. We compare 4 different tutor options, including video, non-avatar AR instruction, AR plus half-body avatar, and AR plus full-body avatar. Machine task in a workshop or factory usually is a compound sequence of different types of human-machine interaction, including local interaction, which requires no spatial movement, spatial interaction, which requires large spatial navigation, and body-coordinated interaction, which requires collaboration of body, hands, and eyes. Prior machine-related work has explored video and AR-based tutoring systems, primarily for local interactions only. However, due to the lack of bodily representation of the tutor, they are not as effective for spatial and body-coordinated interaction. On the other hand, virtual avatars have been broadly used to represent the embodiment of human users in various VR and AR applications. Therefore, we propose to adopt virtual avatars in machine task tutoring scenarios as an enhanced tutor presence to existing AR instructions. In order to find out the strengths and limitations of different tutor presence and use them accordingly to achieve optimized tutor experiences, we conducted a study comparing 4 tutor options, including video, non-avatar AR, half-body+AR, and full-body+AR, with all tutorials created from the same source of embodied demonstration. We specially created a mock-up machine as a machine task testbed, which is capable of supporting local tasks, spatial tasks, and body-coordinated tasks. We invited 32 users for a 4-session study. In each session, the users followed a different tutor option to complete a machine task sequence. We acquired the task completion time and accuracy data from the video recordings of the user's first-person AR view. Each user also completed a questionnaire after each session and voted for their favorite tutor option at the end of the study. We now present the primary findings. Overall, based on the questionnaire result, the tutor options with avatar received higher subjective ratings than non-avatar options. Most users thought the virtual avatar significantly improved their task understanding and attention allocation, especially for spatial and body-coordinated interaction. Between the half-body and full-body avatar, half-body is the preferred choice for spatial interaction and machine task overall. Because the half-body avatar delivers similar functionality as the full-body for guiding spatial navigation while having less virtual contents, which causes less occlusion and visual distraction. On the other hand, due to its higher similarity to a real human, the full-body avatar has slightly more votes for body-coordinated interactions, resulting in better bodily movement understanding and a higher social presence. For local interaction, while the extra avatar visualization is not necessary, users picked the non-avatar AR as their preferred tutor option due to cleaner view and higher efficiency. It is clear to us that video is the least preferred option among the 4, mainly because of the translation gap between the digital video and the user's physical reality. Users reported distracted attention, fractured spatial mapping, high mental effort, and non-optimized perspective while using video tutorials. We have summarized the highlighted results into a list of design guidelines which can help the future design of machine task tutoring systems. For more details of the study, please refer to our paper.